The overall goal of this procedure is to quantify the uptake of nanoparticles into tumors using intravital imaging. This is accomplished by first deshelling and culturing avian embryos. The second step is to establish xenografted tumors in the chorioallantoic membrane, or CAM, and allow them to grow for approximately 1 week. The third step of the procedure is to intravenously inject nanoparticles into the CAM and perform real-time intravital confocal imaging of the xenografted tumor. The final step of the procedure is to excise and section the tumor. Ultimately, the uptake of nanoparticles by the tumor is quantified from the images, and secondary tumor analysis can be performed.
The main advantage of this technique over existing methods is that it allows for the generation of high-resolution images to assess the dynamics of nanoparticle accumulations in tumors at the microscopic level. Furthermore, using this model system, it is possible for a single researcher to analyze a very large number of experimental groups within 2 weeks. Additionally, the chorioallantoic membrane of the shellless embryos are easily accessible for physical manipulation and non-invasive imaging.
My laboratory is focused on the development of nanoparticles for targeted molecular imaging and drug delivery in cancer. Our search for a rapid and inexpensive xenograft model in which to perform detailed uptake analyses led us to the shellless chicken embryo. Here, we use high-resolution intravital imaging to evaluate nanoparticle uptake in human tumor xenografts in a modified shellless chicken embryo model.
For this protocol, prepare shellless fertilized chicken embryos at day 4 using the standard method. Ensure that the embryos are fertilized and viable by checking for a heartbeat, and incubate them at 38 degrees Celsius.